Okay, so in this question we've given a function here, y equals x plus 1 times x minus 2, which is a fairly simple quadratic function actually, because it's just x squareds in there. And okay, so they've drawn a graph for us, so let me just sketch that here. You don't need to sketch it out again, but it's saying that the region bounded by the curve in the x-axis is denoted A. So we've got this going through here and coming up here, kind of like that. And there's an area under here which is called A, and an area over here which is called B. And across here is K. Okay, so the region bounded by the curve, the positive x-axis, and the line x equals, so that's B here, so this area here. So what you're asked to find is find K if area A equals area B. Okay, so let's actually try and understand what the question's asking. So we've got this function here, which we know that the points of, so that's 2 over here, and minus 1, because that's when this function's 0. So we know we've got this area here, and this value k. So the thing is that this, if k is a very big value, so if k is way out here, then this area B is going to be much bigger than the area A. On the other hand, if k is a very little value, say here, 2 point something, then this area B is going to be less than this area A. So what we're trying to figure out is how far along this axis do we have to move k till the two areas are the same. Okay, so that's what we're aiming to find out. So it's now that we know that, the question's actually not very hard, because let's figure out area A, because that's a fixed area. So the area A is the integral from minus 1 to 2, because that's where the graph cuts the x-axis, and we know that because we just plug minus 1 in there and you get 0, plug 2 in there and you get 0, of the function. So x squared, x plus 1, x take 2, dx. And you can figure that out. You can use a calculator for this, but I'm just going to do it by hand because it's easy enough. So it's x squared. I'm just multiplying this out now, minus x minus 2 dx. And that's an easy function to anti-differentiate. So you get 1/3 x cubed, take half x squared, take 2x. From minus 1 to 2. Okay, so now you don't need to go through all these steps. You can just plug it into your calculator, but let me just do this to show off. So 8, so I'm plugging the 2 in here. 8/3 minus half times 4 is 2, minus 4, subtract. Just plug minus 1 in there, so you get minus 1/3, minus 1/2, plus 2. So what have we got here? We've got 8/3 minus 1/3, so it's 9/3, which is 3. 3 minus 2 is 1, minus 4 is minus 3, minus 3 plus 1/2 is minus 2.5, okay, well, we end up with minus 4.5, so minus 9 over 2, that's what we're going to end up with, if you do all the maths there. Okay, so that's the answer to, that's the area of A. Now, what's the area of B? Well, B is the, so by the way, so this is minus 9 over 2, okay, so it's negative, which is correct, because this area here is below the x-axis, so that is negative. So, actually, area A is 9 over 2, okay, so the integral is minus 9 over 2, but the area is 9 over 2, so we'll keep that for later. For B, it's a positive area, and it's going from 2 to k, because we're going from the point 2 up as far as k, of this function. Integrate that function. Okay, so now, actually, we did need to anti-differentiate it, so if you hadn't done that before, you'd need to do it now. Okay, take 2x from, what is it, 2 to k. Okay, so let's multiply that, let's evaluate all of that. So let's plug k in first, so we get 1/3 k cubed, so it's k cubed over 3, minus half k squared, so k squared over 2, minus 2k, and let's plug 2 in here. What are we going to get? Actually, we plugged 2 in here, didn't we? So it's this part here. So what's 8 over 3 minus, so it's, what's it? Let me actually write it out. 8 over 3 minus 2 minus 4. So that's 8 over 3 minus 6 over 3, which is 2 over 3. Yeah, so minus 4. So we're going to get plus 10 over 3. Is that right? I think that's correct. Minus 2. Okay, so you can get a minus 10 over 3. Yeah, and then that becomes a plus. So you end up with k cubed over 3 minus k squared over 2 minus 2k plus 10 over 3. So that's the area of B. And what we want to do is make those areas equal. So A equals B when all of this equals 9 over 2. Okay, and now you can solve that. Plug that into your calculator and solve it. And when you solve it, you're going to get two values. You're going to k equals minus 1 or k equals 7 over 2. Okay, so which is the correct answer? You can reject k equals minus 1 because k is way up here, and it's actually k equals 7 over 2. So that's our answer. Just as an aside, I just want to explain what k equals minus 1 is. So we rejected it here because we said it's obvious from the graph that k has to be bigger than 2 here, so it can't be minus 1. But just think what k equals minus 1 means. What that's saying is that if k was minus 1, so we've got this graph here, let me sketch it out for you. So the graph here crosses from minus 1 to 2, and this area here is A. Here, under here. So what our maths, the gods of maths are telling us, is that if we went from 2 and went back to minus 1, which is in other words if k was back here, then we'd get the same area. And that is right, isn't it? It's exactly the same area. So even though we want the one that's out here, which has this area here, which is equal, we could equally get the same area, but going back to minus 1. So that's what the k equals minus 1 is. This just as an aside, but it does show that when you do pure maths like this, every answer that you get does mean something. It just is in some cases, it's an answer that you can reject for a certain reason because of the way the graph is shown in this case, but actually that answer could mean something in another context.